All right, so today we're going to look at just one example in this video and what we would call a farmer problem. You'll notice these are called farmer problems because they're always talking about farmers. It's always talking about some farmland, some fencing, and it gives you some kind of scenario about the layout of their land. And in this case, it says that the fencing in this region that has a river on one side. It does help definitely to draw a picture and to understand that the measurements in which they give you, they're either going to be a perimeter or an area. And so as you continue reading, it says he has 400 feet of fencing. Now let me make it clear that if it's an area, it would read feet squared, right? Because we know that area and the units that are measured are squared. Of course, if we were talking about volume, it'd be cubed, but that wouldn't be the case when we're dealing with these quote-unquote farmer problems. So the farmer wants to maximize the area that is fenced in, and this still goes alongside the quantity questions that we've been dealing with. See, because the quantity that we're looking at, instead of labeling it as Q, we're talking about area. Now we could still leave it as Q and just say, okay, we have an area that's being fenced in. But again, what exactly are we looking at here? We have a farmer who has a region that has a river on one side. And so you have a river, right? And we want to fence in an area. And so this is kind of what you're looking at. Now let me also say that some of you might have interpreted the river to be up here. And so you have a box drawn this way. And although you're like, well, what difference does it make? It really doesn't, except we deem X as being those horizontal lines and the Y being the vertical. So if you were to do the one like we see here on the right, then it would have two Y's as opposed to two X's in terms of fencing. So our approach would be slightly different. Now the other piece of information that they tell us is that the amount of fencing that they have is 400 feet. So when you're drawing this fence, okay, when you think about it, we know that the perimeter of this fence is 400 feet. So X plus Y plus this X is going to total 400 feet. Or if you're doing this one, it would be 2Y plus X is going to equal 400. Again, it really doesn't matter which one you do. And when we're talking about area of anything, it's always X, right, times Y, or length times width. So in either scenario, it's going to be X times Y. Now, from here, what you're going to do is you're going to solve for one of the variables, because as we've talked about with these quantity questions before, when we want to maximize or minimize the area, what you're basically looking to do is to get Y or one of the variables alone, so that when I do the derivative, it's in terms of just one letter. So this would be Y equals 400 minus 2X. So this becomes X times 400 minus 2X. And just to multiply that out, that's 400X minus 2X squared. So if I want the maximum, then what I'm going to do next is, of course, the derivative. You guessed it. So I have 400 minus 4X, and I want to see when will that equal 0. And so easily done. 4X equals 400. X equals 100. Now it says he has 400 feet of fencing. He wants to maximize the area. I can't really tell what it's asking for here. He's fencing an area, has a river on one side. I'm just going to find all the information that's needed here. So X is 100. That means this is also 100. If I have 400 feet of fencing, 100 and 100 make 200, that means that Y is 200. That would mean that my area is 100 times 200, giving me, of course, 20,000. And we're talking about feet, so feet squared. And that is basically what a farmer problem is. It's still another one of those max-min questions that we've been doing. However, it's just a slightly different wording because it's dealing with farmland, I guess. So, and those are your farmer problems.